Welcome to Brain Vision.
In this question, we have a pendulum that is swinging with a maximum angle of 45 degrees. The first part of the question, we want to find what is the speed of this pendulum when it passes through the vertical. Now, when it passes through the vertical, it means it has the highest kinetic energy because its gravitational potential energy has all been converted into kinetic energy. And so what we need to find is the difference in height between its highest point and the lowest point in order to find what is the change in our gravitational potential energy, which will give us our maximum kinetic energy. And from there, we'll be able to find the velocity because our kinetic energy is just half mv squared. Now we know that at this particular point, the height over here can be found by a trigonometry. So this is just the length of the string L times cosine 45 degrees. Now the length of the string is given to be 0.8 meters. So this is just change in the potential energy just from L cosine 45 to all the way to L. Right? So the change in the height is basically L minus L cosine 45 degrees. Multiply this by mg. L is given to be 0.8 meters. Multiply this by 1 minus cosine 45 degrees. Mass of our rock or pendulum is 0.12 kilograms. And G is just 9.81. We equate this to half mv squared, in which we can actually get rid of the mass m, right, because there's an m over here. So this is just half v squared. We can get v by multiplying this expression by 2, and then we take the square root. We should get 2.1 meters per second. So this is the velocity. Now we want to find all the tension in the rope at two different points, right? So the first point is at this particular point when it is at its highest height, and the second point is when it is back in the vertical position, right, at this point. So for the first point, when it's at its highest height, its velocity is 0. This tells us that the radial acceleration, right, v squared over r, is equals to 0, right? Because there's no velocity, tangential velocity, and so the radial acceleration must be 0. And so what this means is that the pendulum basically only experiences this tension and the weight mg, since it has no tangential, it has no radial acceleration. The only contribution in the radial direction is the radial component of our weight. So the radial component we are looking at is this particular component of the weight, which we can get via taking cosine, since this is our angle 45 degrees, and so we can just take mg cosine 45 degrees to be equals to the equals to the tension in the rope. So this gives us 0.83 newtons. On the other hand, if you were to consider the second case, when it is at the bottom, now it is moving with some velocity, and therefore there needs to be some tangential acceleration, right? Because it's moving in a circle, so that the net acceleration must be equals to the circular motion, which is v squared over r, right? Is the acceleration, centripetal acceleration. Now we know that via the free body diagram, the net force acting on the pendulum is the tension as well as the weight, mg. So the net acceleration is basically t minus mg over m. Right, this is the net force, and this is the mass. So we just take net force divided by m to get the net acceleration. To get our t, it's be mv squared over r plus mg. The velocity we have previously calculated, which is 2.1 meters per second square. So we just take m times 2.1 square divided by r, the radius of the circular motion, which is the length of the string, 0.8 meters, plus 9.81. And we should get 1.9 newtons. So this is the tension in the string.